Hello. Welcome, everybody. We are starting this new Meet for Speed again. I don't know. We move it around a little bit. Sorry if it was a last moment update, but um, hopefully you can join us and we'll do some optimization tonight and talk about ways to speed things up. Um, my name is Sergey Chernyshev, and I have with me Paul Calvano.
Hello.
Hi, Paul. We are both organizers of the group, and you see this page on the screen. This you probably came through this as a member of New York Web Performance Meetup, but we are now online, so I don't know how New York it is. One day we'll go back to the in-person events like this. So if you are in New York and you want to host in-person Meet for Speed events at your company, please let us know. Sorry about that. I was so overwhelmed with the idea of going back in person that I, yeah, lost my voice. So please say hi where you are, because it's always awesome to see where everybody is and to know who has joined us. It's much harder in this medium online, but as Paul and I were just discussing before we started the streaming, but um, hopefully it's still enjoyable and you will all like it. In addition to this Meet for Speed events, as regular members will know, we also run speaker sessions, and like you can check our recordings on the YouTube channel. In fact, last month's recording was just posted the other day, and we'll send the announcement shortly that it's live. But also this month on June 22nd, we will actually have another in-person event. So if you want to join us at Dot Dash Meredith, their team is going to talk about a couple interesting talks about optimizing loads versus like preloads, early hints, fetch priority, and things like that. And they're going to talk about their advertising management and advertising performance, which is both very interesting. So we'll start at 6 o'clock. There will be food, giveaways, in-person chatter, and everything we love about uh, those kind of things, like live events. So please join us. Um, what else? One last word of introduction. I want to talk about our sponsor, SpeedCurve. SpeedCurve is a monitoring company. They do synthetic testing, and that's how they started. Awesome charts, awesome data, and now they also have real user monitoring as well. And they build awesome dashboards and analyze would help you analyze your performance. Perf budget setup is pretty cool, and then well, we like it's all awesome features that you can go there and check them out. I'll paste a link in the chat as always, like this. um, so go check them out.
And I think we lost Sergey. Um,
And I'm back. Nice. That's what I get for reloading the wrong screen. um, that's how it rolls. But I was about to switch uh, to our main event tonight anyway. So uh, we are still good to go. Where's my link? Where's my link? Yeah. So Paul, take it away. Paul will be analyzing a website, and we'll start the conversation from that.
Great, thanks. So, hi everyone. So it looks like Sergey will put um, in the chat a link to the form to request a site to be audited. looks like we've got one right now, rci.com. So I'm going to actually go ahead and share my screen, and we'll dig into RCI. But if anybody has any other sites they want to look at, throw it in there, and if we should have plenty of time to go and look at another site or two.
Yeah, and the URL is also right there on the screen, right below the video, so you can also see it there.
The one thing I wanted to do just before we jump into the RCI audit is this newsletter. So Sergey, if you can share the link to that in the chat, that would be great. But this newsletter from Smashing just came out this week, and it is excellent. It's got a whole bunch of web performance topics in it. But one of them in particular is this performance strategy doc that Vitaly did it. So actually, I could find it here. This performance optimization strategy in 2023. So Vitaly Friedman had put this together, and I think that when we go through this audit today, we're probably going to kind of pick and choose from a couple of these things, and then just go and see what we can find. But yeah, Sergey, if you can put both of those links in the chat, that would be great.
We'll do in a sec, yeah.
So I guess we'll start off by looking at the RCI homepage. So so this is a travel site. You can see there's a big hero image here. There's there's a video. The page length itself is not very long, but there's a lot of content on here. And yeah, let's dig in first and take a look at what I'd like to do is try to understand a little bit about the site's current performance from real user measurement data. And what we can do is use the Chrome User Experience Report data. So I'm going to look at trio.sh, which gives me this way of visualizing Crux data. And so we can actually see some of the real performance data from RCI. Looking at this, I can see that their time to first byte is very high at 2.2 seconds. It looks like that's remained fairly consistent throughout the year as well. And that's at the 75th percentile. Looks like first contentful paint and largest contentful paint is also high. However, looking at the distributions for this, it looks like they've definitely made some strides in terms of improving all three of those metrics. And then interaction to next paint, it looks like this year they've done a really good job of optimizing for that. I guess another thing that I was curious, because like when you look at the traffic stats by location, and this is a travel site, US it's 4.8 seconds, and France it's 5.4, and Spain it's 5.2. I was curious to see like where, like we can't tell from the Crux data what the distribution is of the actual users. That's something that RCI's RUM data would probably have, but we could probably get an approximation of that with another tool called SimilarWeb. SimilarWeb provides kind of this public snapshot of sites. I think it's mostly used by like SEO folks, but over here I can actually see that some of the data that they've collected is showing that about 3/4 of their traffic is in the United States, and the next most popular country is Brazil. So Brazil, Canada, and Mexico. So kind of going back to the Crux data here and just looking at it's 4.8 seconds in the US, 4.8 seconds in Brazil. And so it looks like the performance is fairly consistent across the geographies that the site is primarily serving. So that's good to see. Let's see. So yes, kind of like digging a little bit deeper into this. There's a couple of tools that so WebPageTest, I think, kind of goes without saying. Like we'll be spending a lot of time with WebPageTest. There's also another tool called Yellow Labs tools that we'll look at, and then there's DevTools, the performance panel in Chrome and things like that. So I'm going to pull up the.
Sorry, Paul, can I interrupt you for a sec? Can you bump up the font size on your screen so when you share these docs so people can see it a little better?
Sure. Is that better?
And also, can you share that Crux URL for this website, like the one that you were sharing right before? There you go.
Sure. Yeah.
You can paste it in the private chat. I will cross post it in the stream.
Okay. Cool. That's what I wasn't sure if I was able to.
Yeah, it's broadcasting, folks, is an art and a challenge. Let's put it this way.
Okay. Cool. Did you get it?
Yeah, I got it. Thank you, Paul.
Okay. Cool. Now I know how to send you links. Yay. Okay. And so I'll share the other one for SimilarWeb. And
I posted the other one already.
Did post that one? Okay, cool. All right. I'm going to close out SimilarWeb, and I want to pull up the Yellow Labs tools site. So if we go here and just kind of click on Yellow Labs tools, so you get to choose kind of a simulated device, phone, tablet, or desktop in HD, and then you run an audit. I ran one a little while ago, so we can kind of look at that. It gives you like an overall score, and it tells you some details about that score. And so it looks like the page weight was very high. It pointed to some image optimization opportunities. gzip and Brotli, this was kind of surprising that there's a 775 kilobyte opportunity for gzip compression. File minification, images out of the viewports. And I think and caching. So I think that like just kind of looking at this tool, like that, it kind of gives us a few areas to look into. The one that really caught my attention was this gzip Brotli compression, because I normally don't see that much of a savings from, in terms of opportunity. But it looks like the big, it looks like the big opportunity here is this cdn.whatfix.com third party. So this third party is introducing 1.3 megabytes of JavaScript, and that's compressed JavaScript. That's quite shocking. And that's already gzipped. So just kind of looking at this payload here. So there's a tool that I had written a while ago that allows us to kind of estimate Brotli compression levels, gzip compression levels. What this does is this will take this URL, it will download it, it'll try to download it gzip compressed, it'll try to download it Brotli compressed, it'll decompress it, and then try to recompress it at every level of gzip and Brotli. And then based on that, it'll guess the compression level that was used. And so it looks like this one was gzip compressed to a very low compression level, because like even like the defaults for most web servers would still shave off like another 100 kilobytes from this. So I definitely think they should check on their origin, so on their web servers, what their compression level settings are. And this isn't an RCI issue. This is a whatfix.com third-party issue. The other thing is if we look at, I'm going to open up a terminal. I'll make this a little bit bigger. If we do a lookup for cdn.whatfix.com, we can see that that's actually using Cloudflare. So Cloudflare's a CDN. They have they will gzip compress your resources and Brotli compress your resources for you. Much like other CDNs, that I've worked with, I believe they do is if the origin server, so if whatfix.com server is sending a gzip compressed resource, they will cache and serve what that origin server had compressed. But if it was uncompressed, they would recompress it, and they would compress it and that compression level would be at a higher level of compression. However, with most clients supporting Brotli, if they turned on Brotli compression, they could probably shave 28% of this payload off. And this is still a massive, massive third-party bundle. I would question why they're even using it, and if it's providing the value that it's costing them. But aside from the point, I think that like WhatFix could do a lot for their users by just enabling better compression levels.
Why do you think it was misconfigured?
So I did some analysis on this years ago, and one of the and I should probably check to see like what server they're using, but like Nginx, their default gzip compression level is 1. And so if they are using Nginx, I don't know if they're rewriting it. They have Cloudflare rewriting the server header, so I can't tell what web server they're using. But if they happen to be using Nginx has a default compression level of 1.
Yeah, I remember originally Apache didn't want to gzip by default either. It was a big fight back in the day. But I actually don't remember what the Apache's default was after all it's settled. I hope it was 6 or something.
I think Apache's, and so here's actually from the Nginx documentation. So the gzip level compression, the default is gzip level compression 1. So that is still current as of today. Is surprising.
Somebody prefers to spend less CPU but have their connections open longer.
This is true. Yes.
I guess since Nginx is event-based, unlike the original Apache, where each connection will mean opening another child, right? Like spawning another child. They are like, I don't care. Like let them hang, right?
Yeah, I think that it does wonders for benchmarks, and Nginx always scores really high in the benchmarks. But like for real world practical uses, it's certainly not ideal to keep those default settings.
Yeah.
While we're on the topic of DNS, I just want to take a quick look at, so if I do a dig for www.rci.com, so they are using Akamai. And so with Akamai, the www.rci.com is CNAMEd to www.rci.com.edgekey.net. And then the way Akamai works is that will also CNAME to another host name. And then finally, it resolves to an IP address. This first resolution here is what I kind of want to talk about, because this first DNS resolution has a very low DNS TTL. And I think that they should consider increasing that. Usually, like the reason why some sites will keep a very short DNS TTL is because they're like load balancing multiple CDNs, but that doesn't seem to be the case. I ran a DNS lookup before from multiple locations. Actually, I'll show you real quick. There's a really cool DNS propagation tool that's called What's My DNS, where you can fire off a DNS lookup from a whole bunch of different sites. And so to just kind of show you, like Etsy uses multiple CDNs, and if I just say, give me the CNAME record for Etsy, I can see that it's either going to Akamai or Fastly. But when I do the same thing for RCI, it's consistently going to Akamai. So I believe that they're just using a single CDN. And if that is the case, I think that there would be benefit to increasing that DNS TTL. Another thing that they could consider doing on the DNS side, and I can also share I'm going to share that link in the chat as well. I got to remember to keep sharing links. So I guess another thing that we can look at with DNS is if we do a dig NS for rci.com, we can see what DNS service they're using. And so it looks like they're using Akamai's DNS service. Now, Akamai's DNS service has a feature that I think they should consider using. And when you configure a zone on Akamai, I think where's the adding record sets? Okay, so supported resource record types. There's a bunch of different DNS record types. So they're using a CNAME, and they're CNAMing the go back to the RCI DNS lookup. They're CNAMing to www.rci.edgekey.net. One of the things I think they should consider doing is using the Akamai CDN name, because then what they can do is have Akamai resolve www.rci.com to an IP address. It prevents this DNS chain. It makes it so that you don't really have to worry about this short DNS TTL or this DNS TTL. And so it's just kind of a cleaner way of doing things. So I think that they should consider doing that as well.
And this is a special Akamai's DNS record type, right?
Yeah, a bunch of the other named servers. I think we use NS1, and there's a few others, but they have similar like CNAME type of record types where it's like it'll perform the CNAME for lookup for you. So this is similar to that. I think it's just kind of got a special integration with Akamai as well, so that it doesn't give you the edge server that's closest to the end user, but it gives you the edge server that's closest to the end user, but not the one that's closest to the resolver. Yeah, it's kind of getting a little bit in the weeds, but I think they should look into that. So let's see. Yeah, that's all I wanted to talk about DNS. If I kind of go back to this dashboard over here, I'm going to switch to WebPageTest in a minute because you can go a lot deeper. The image optimization here, so it's showing that it scored an F on image optimization, and you can see that some of these images are massive. Like this image is 1.5 meg. That's the main hero image on the site. So this one here is 1.5 meg. So that's most likely their largest contentful paint image as well. But let's actually go and switch gears and look at WebPageTest. So this is a WebPageTest measurement that I ran this morning. I just used a Galaxy S7. I wound up running at a very high connection speed. We can try going to a slower connection speed later. But just looking at some of the performance metrics here, you can see that in this case, the time to first byte was a bit faster than we saw in Crux. The page weight was 7.6 meg. There's a really, really high total blocking time. And largest contentful paint was actually faster than we saw in the real user data as well. So that, like this feature in WebPageTest, I feel like it's always really important to look at this when you're looking at an individual test result, because it will give you a sense of how representative the test that you just ran is of your real user data, right? So you can see that the first contentful paint that we measured here was actually kind of on the slower side of what end users experienced. And same thing with the largest contentful paints, like the real user data is a lot slower than what this particular test experienced. That's some of the other metrics probably, or some of these metrics are probably because I ran this at a very high connection speed. And then if we take a look at some of the test runs, just kind of scrolling through and looking at individual. So this is first view and then repeat view. I can see that the repeat view has a lot less requests, so it looks like they are doing a fairly good job of caching. And just kind of from this high level view, I see a lot of purple here. So there's a lot of images. I also see a lot of requests. So we're just going to go and pick one of these measurements. I think the median measurement is run 3. So why don't we go hit that one?
Before we look into that, I actually want to say that you started with the rule-based yellow labs, right? And that's nothing wrong with that, folks, right? Like if you can get that quick assessment with a yes, no kind of A to F mark, and you can like immediately jump and you know what to optimize, most likely that will be a good thing to optimize. Sometimes it would tell you, hey, you use a third party that is not perfect and you cannot do much about it. But but a lot of these recommendations can make a lot of sense. So
yeah.
I know we deep dive here, right? Oftentimes, right? But sometimes you can start with just those early answers. And same goes for what just Paul did. He just looked at the like very low resolution waterfall and said, "Well, I see some purple.
Yeah.
I see a lot of requests." That's kind of like very good, quick assessment that you can do.
A lot of what I found is that a lot of performance analysis is recognizing patterns. So once you start to work with a bunch of different websites and analyze a bunch of different websites, you start to notice the same patterns happening over and over again. So you can kind of look at that like 10,000 foot view and say, I think I know what's going on here. But yeah, and to your point, Yellow Labs and WebPageTest are both synthetic tools. I feel like WebPageTest you can go way deeper in terms of in terms of doing performance analysis. Yellow Labs has a couple of things that I don't get in WebPageTest. Like one of them that I really like is this ability to find identical content or empty requests. So that's usually like those two features are usually when I'm doing audits is one of the things I tend to look for in Yellow Labs, and the rest of it I can usually get from WebPageTest. But I think both tools are helpful, and it's always good to get like multiple perspectives on what different tools are saying, and you can also get like scoring from Lighthouse and recommendations from Lighthouse, and then WebPageTest also has the opportunities and experiments where it will tell you that things that are where there's performance issues. It's always really good to look at all of those to get a sense of what the tools are telling you to do, but then you also got to put on your analyst hat and look at it and say which of these are the most impactful and where should I prioritize my efforts? Because I can get a huge list of defects or performance issues, but deciding like where to actually spend my time becomes I think the next important thing. So yeah, let's take a look at this. So I'm gonna start with the very first request. And so this is a request for www.rci.com/ and this had a 514 millisecond response time, and it actually returned a 302 redirect. It's not cacheable, and the redirect was to /pre-rci/us/en. So that kind of looks like a geographic redirect, but it also looks like they're setting a bunch of other cookies here. So they're setting some cookies for their real user measurement tool. So this is App Dynamics RUM. They're setting an XCRF token, a JSession ID, some user locales, and then they're directing the user to the correct location. So this seems to be taking more time than actually loading the HTML page. The other thing, just kind of looking at, well, actually, let's go to the next page. So let's look at the HTML payload. So I can see that the reason why the HTML page is so fast is because they're actually caching the HTML. So the browser can cache the HTML. The CDN is probably caching the HTML as well. We can also check that too. And I'll show you how to do that in just a second. But one of the things that I thought was really, really puzzling about this was these two headers over here. So we know that this...
Paul, can you bump up the font? Sorry, I will keep reminding you. Sorry, folks. I will bug Paul about it.
Sure. Paul is bad. Paul is bad at this. Okay. So, oops. See, I'm bad at streaming. Okay. Xserve by and Xtimer. So these two headers, so this is showing like a cache location that this request was served from, and this is saying it was served from a Chicago cache server. But this header is, and this Xtimer header is specific to Fastly's CDN. So why are we seeing Fastly headers on a response that was served by Akamai? And so what I believe is happening here is that the request is being routed to Akamai, and then Akamai must be going forward to a Fastly service, which is then going forward to the origin. So I guess one of the questions would be why we use two CDNs. There's certainly valid reasons for doing that. Sometimes you have a content provider or a service provider that is using one CDN and you want to have more control. Sometimes it's because you're using multiple features or you're testing something out, that maybe one CDN's got a feature that the other doesn't. But at face value, it could seem inefficient, and it doesn't mean that it is. But it was definitely interesting, and if it's not, if it's a surprise to anyone, then I'd certainly investigate it. But it's probably being done that way for a reason. But so the and I mentioned that I believe that this page is cacheable on the CDN. So part of that is because the time to first byte is really, really fast. So the time to first byte is 27 milliseconds, which was about a little bit it was a little bit slower than the initial connection time. So like it's a very small it's it's a very small amount of time that it's taking for this HTML to be generated.
Yeah, it's very surprising. You rarely see those kind of numbers these days.
Now,
Yeah, I guess maybe some of it was hidden by the redirect, like the fact that redirect has happened, but it should be just the connection that you're saving there, not time to first byte, right?
yeah. Well, so I'm going to refresh this page here, and there's a feature. It's share a link to it in the chat as well. So since this is using Akamai, there is a feature called Akamai Pragma headers. So I'm using an extension here that is essentially saying add this Pragma header, and it's I'll show you the Akamai documentation where I got that from. You're adding these request parameters, and it gives you some information back. And so I'm going to go ahead and add that in DevTools. I've got that Pragma header enabled. So before, just to show you, this is, well, actually, I'll just refresh it and you can see it. So here is the response header now with the Akamai Pragma headers. You can see a lot of these x-Akamai or x-cache key and so forth. And so I can see that this was a TCP mem hit. What that means is that it was a cache hit on the CDN, but it was also so popular that it was stored in the server's memory as well. So you'll usually see things like TCP hit or TCP mem hits, or miss would be a cache miss. If something was not cacheable, you'd probably always see a cache miss. But in this case, I can see that this is a TCP mem hit, so I know that the CDN is caching this, and that's why that time to first byte is very fast.
Gotham is asking, what was the extension you were using to inject Akamai headers?
Oh, sure. So the extension I was using was, what's it called? Mod header. So I'll share that in the chat as well. Yeah, I like that. I like this extension because I can just very easily go and like add headers or change cookies and modify response headers and so forth. I believe there's plenty of other tools that you can use to do this, but yeah, that's the one that I tend to use the most.
And what are the headers that you are injecting? Oh, can you share this link as well?
I'm sorry? Oh, so again, this is me being bad at streaming. I thought I clicked send, but I didn't. So here's the header that I'm, oops. Now those headers are not going to be something that you can see on every website because certain websites will disable those headers so that you won't be able to actually see those headers. So if you don't see them, you probably don't have the ability to see them. But for sites that don't restrict those headers, you'll be able to see them and kind of understand what the what the CDN is doing.
Yeah, and each provider would probably have these kind of headers documented, or you can reach out to your support team that will tell you what is available to you.
Yeah. Okay, so going back to WebPageTest. So now we've got the HTML. So most of our time so far has been spent loading, essentially loading that redirect, and getting and then a very small sliver of time was spent downloading the HTML. Now we've got a couple of CSS files and a couple of JavaScript files. These are render blocking, which is what that X is indicating. And then we've got App Dynamics' RUM solution. So this is they're much like we were looking at Chrome user experience report data before. They're also using they're also deploying a commercial RUM solution called App Dynamics. So that's giving them performance data. And then it looks like there's a third party for Salesforce Live Agents. And if we kind of zoom in on that, and I'm going to zoom in by scrolling down here and customizing the waterfall. If we zoom into like the first 2 seconds of this waterfall, we can see that they're doing a DNS pre-connect for this Salesforce Live agent. So it'd be interesting to see like where that is happening in the HTML. So let's actually go back to our source and take a look at the HTML and see where Salesforce.
Interesting.
There's a script here. I don't see it. I don't see a DNS pre-connect. I don't see a DNS prefetch in here. I also don't see pre-connects in here.
Is there one for maybe it's a header, not HTML tag?
Let's double check. So yeah, I don't see a link header either.
Interesting.
So I don't know how or why. That is puzzling. I don't know why the DNS lookup is happening earlier. I would certainly pre-connect this. So using link rel pre-connect to get the entire payload here. I don't think this is blocking. It looks like what is blocking is this critical JavaScript here. And you can kind of see this like almost like step pattern where like we've loaded the HTML, redirect happened and then the HTML. So the HTML was dependent on the redirect. And then there's the critical CSS and JavaScript. The third party loaded, the third party objects loaded while the browser's main thread was busy, and then the rest of the content is loading. So there's definitely some long tasks over here that we could try to investigate and try to understand what's going on here.
Do you know if this gap between the DNS portion of the request and the wait portion of the request could have been for other reasons, like maybe hogged CPU or maybe browser prioritization, like 3 scripts already loaded, we can delay this one or something like that?
Sorry, can you repeat that? So
is the reason for the gap between DNS and the wait time, right? That's what you are assuming is causes for pre-connect, right? Do you know if there's anything else that can cause
it? So I didn't see that domain referenced anywhere in the HTML source. Let's actually go and take a look at since we ran 9 tests. Let's go see and just see if this is a fluke. Right. So we were looking at test number 3. I'm going to go and look at test number 1 now.
And by the way, just heads up, we do have a couple more submissions. So if you will want to shift to the next one later, feel free to go there.
Okay, awesome. I will. I'll spend a few more minutes on this, and then we'll switch.
Awesome. Yeah, awesome. So folks, please stay on. Don't feel like we are looking at not your website.
Yeah. Okay. So
ask your questions and all of that.
It looks like every single one of these that I'm seeing had a DNS lookup.
Detached, basically. Right?
Yeah.
Interesting.
So over here, there's like this long wall of tiny PNG requests here, and it looks like it's lots of countries. And if we go back to RCI's websites, don't really see anything over here that, but like if you go and look at, so from mobile, if I go and I click on the hamburger menu and then I click on this menu for the dropdown, I can see that they've got every single flag displayed here. Now,
Looks like these images are more important than the content images on the website.
yeah. So that, and I think that's what's happening here, is that images are generally low priority requests in terms of H2 prioritization, but these were probably at the top of the body. So if these images happen before these images, which were probably more important, they all got fired off at the same time and then returned in order. So in this case, I think that what we're seeing here is a lot of these images that are really, really, really tiny are just getting are just taking away from some of the time that these other images would have been able to start loading in. Now, if we also take a look at some of these images, you can see that there's 1 kilobyte of content for each of these images.
Yeah.
So these are super tiny. Well, some of the flags have more content, like 4 kilobytes. Actually, these here 3.4. No, download is 1 kilobyte. So these some of these could probably be inlined. They could be inlined into the HTML with like URI encoding.
But if anything, I would lazy load them, right? Like,
yeah, or you could
who
lazy
cares
load.
about the images in the drop down that people didn't even click yet?
Yeah, I think that you could probably do some research too to see like how often are users clicking through to this path here, and if this is not the most important thing, which I truly doubt it is, then I would not give it the priority that it has. And lazy loading would be the most effective way of handling this, I think.
I actually have a question that I was wondering, and I'm not as familiar with browser prioritization schemes and server prioritization schemes, but obviously, if you fire that many requests at the server, does the browser actually fire that? Does the browser actually have a limit on how many it will fire? I
Yes.
know HTTP2 is no longer limited like per connection, like sorry, it's not limited to 1 per connection, right? But is there a limit?
Yes, there is. So I remember there was this this feature here, this Akamai demo page. When H2 was first introduced, Akamai had introduced this really nifty feature that showed you, like, over H1 how long it would take to load this, and then over H2, like, poof, right? And so,
Mhm.
but like if you actually go and take like a packet capture and look at the H2 frames, what you'll find is that I believe that there's, I think that it was 100. I think it was 100 that requests that were essentially in flight at a given time.
Mhm, mhm. Yeah, so folks, even though HTTP2 is a groundbreaking protocol, same goes for HTTP3, there are some limitations that are put on connectivity, right? So keep that in mind. Keep that
Yeah.
in mind. And
Now,
obviously, having like the biggest problem here is just having more requests of the same priority early on, so server just never gets to serve the right ones.
this is interesting as well. Like if you look at some of the image names here, right? So like I've got like directory, Las Vegas, rental, travel. Then I've got little unhappy, and little happy, right? So like there's little unhappy and then a little unhappy RCI, right? So like what are these, right? So there's little unhappy, and there's little unhappy RCI. The but like these are I remember back in like the kind of the olden days of web performance, we would used to have like sprites to do some of this, but like still, I think that some of these could be potentially lazy loaded or inlined if they're like super tiny. Like this is 1784 bytes. And but now, like looking at so one of the features I love about the WebPageTest waterfall is that it shows you when the bytes were actually in flight, um, and you can and so by looking at the darker shade, you can actually see where most of the bytes were. right? So, or like which objects were heavier. So like I could also go down to this view over here and sort by content downloaded time and say that, oh, the largest image here was request 87 and it was 1.5 meg. But the same way I can kind of eyeball this chart and say, this is the largest image. I wonder what this is. This is the hero image.
Right? Yeah. So which request number what?
This was request number 87.
87, folks, 87. And
right.
also we can see that there's a lot of striping going on before this main body download, right? So all the images are competing for this download.
Yeah.
Which by itself is interesting, but nonetheless, like you having like the largest hero image effectively delays the display of that image until the rest of the images download.
Now remember, I also gave this a 20 megabit connection, right?
Oh,
and
yeah.
If you look over here, we're using all 20 megabits in order to download those images, right? So that bandwidth was maxed out, and yeah, all these images are competing for that bandwidth because that's a finite resource. Now, so lazy loading is, I think, will do wonders for this, because if you can lazy load the images that are not in the viewport, which, by the way, are most of them, right? Like even on desktop, like if I close DevTools and look at desktop and scroll up, like I see 4 images, right? Maybe 5 images if we're looking at the Salesforce widget, and 6 if I'm looking at RCI. Like there's not a whole lot of image content here, right? But all those other images, and the ones that are kind of hidden by menu items are the ones that are taking up all of the bandwidth. So this is probably also very expensive to deliver as well. And that could be, aside from the user experience, that could be another benefit to lazy loading as well. But let's take a look at this image here. So this is a panorama image, rental opt-2. It's 1.5 megabytes. If I take a look at this, I can see that the cache control says that there's a max age of 600. So this image is cacheable for 10 minutes, which doesn't seem like a very long time. The image is large, and this image was also served through Fastly before it was served through Akamai. It's also a PNG, and PNGs are not the best choice for web contents. JPEG, but really like WebP or AVIF are going to be the better options for delivering this. Usually what I would see a lot of sites do is like if they're hosting a PNG, they'll use like an image CDN to convert the image to a JPEG or convert the image to a WebP. If we actually go and take a look at, so in WebPageTest, there is an image analysis feature here. And this actually sends you to Cloudinary's website. So Cloudinary is an image CDN. We can actually see what Cloudinary's analysis shows of like how much smaller this image could be if it was compressed. And so this is actually showing that there's 4.8 meg of images, and that it can be reduced to about 0.5 megabyte of images. So that is a massive 90% image reduction. Let's go and take a look at the details here. So this 1.5 meg image, converting it to JPEG would be 214 kilobytes. So converting it to the least optimal image format would be an 86% savings. Converting it to AVIF would go even further. So you get to 182 kilobytes. Now, tools like Cloudinary can do that. Their image content's going through 2 CDNs. So it's going through Fastly first. Fastly has an image optimization service, and then it's also going through Akamai, and Akamai has an image optimization service as well. And then there's also other options like Cloudinary and ImageIX and a few others. I think that they should definitely look into lazy loading as well as optimizing the images that they have, because they're serving a very, very high quality image. And I don't think that a 1.5 meg hero image is going to really mean that much to a user that is on a mobile device.
I actually want to quickly chat about that 600 millisecond, 600 second TTL on the image, right? I feel like usually this is done out of fear that you will have resources that you cannot invalidate, right?
Yes.
Or when you publish, you can, and you can see that the URL itself doesn't contain any fingerprint for the resource, right? So basically, URL is not unique to the content of that resource. So they kind of saying, oh, if we upload the same image with a different same URL with a different content, we want to make sure it gets updated, right? But the reality is that first of all, nobody does that. Second of all, implementing fingerprints is actually not that hard, right? Most of the current content management systems allow for that. And even if you don't do that, it just manually just say v2 in the URL. It's not in the file name. It's not that hard, right? And it will do magic in many ways, right? Like starting with the fact that your origin will be able to like not have as many requests to it. I don't know how they are configured. Whatever, like their origin actually has less aggressive TTL, but basically don't have a default of low TTL on your CDN. That's kind of defeats the purpose of it.
Yeah. And just looking at the URL here, you can kind of learn some more from. So yes, there's no versioning. It looks like they added a -2 to the end of this as well. So there might be some versioning happening here, but they're using. So you can see that there's /DAM/ path. So they are using a digital asset management service. They should check with whatever DAM they're using. They should see like if like marketing or wherever they're getting their images from are loading the images into their. So if they're loading images into their DAM, is it going to produce a new image URL or is it going to produce the same one? If it's going to produce the same one, then having that short TTL is probably beneficial to them, but they should probably also look into ways of making it unique so that they can do the caching, because that's going to, again, make a huge difference in terms of load times. And it's also going to probably make a huge difference in terms of delivery costs as well, because that's also probably important. One other thing I wanted before we move away from RCI is so by the way they're loading a Vimeo player, and the video doesn't load until you press play. I think it was about a meg of video content and it was 10-second clip. There's for a 10-second clip of video, there's probably better ways of doing it than loading a player. The player is also below the fold. I would say easiest would be lazy load the player. Just load the player after the onload event. They could also consider just hosting the video and using like the video HTML the video HTML element. But then request number 19 is a request for what looks like the homepage. Right, and so
nice.
you can see rci.com/clocale, and then if I look at the response here, the response actually redirected to the same homepage that we saw before. So what happened here is that we've loaded this this page as an embedded object, and then it wound up going and requesting the homepage again. Now, if I go and I do this in my browser, I'm going to open up DevTools again and click refresh. So I just want to go and filter by domain www.rci.com. I'm going to also filter by content type. So I'm going to add the content type header here. And I just want to filter by content type because I want to find the HTML. And so here we go. I found the main document, and then I found the not main documents. And they are the same size. So they are loading their HTML twice. If they were not caching their HTML, this would be a big issue because they'd be driving their backend utilization twice as hard. We can also see the initiator for this as well. But one of the things that you can also do in DevTools is search for something like across all, like in this lower, there's a train coming apparently by Sergey.
No, I'm on a train. Sorry about that.
You're on a train? Okay. But so in the lower panel here, this search, if you search for something in here, it will search across all resources on the page. And so I'm able to quickly find the JavaScript library where clocale is present. And what I can see here is that they've got this all the way at the end of this bundle here, pre-login sign-in changes. So it looks like as a result of some form of change, they are creating a URL that's the current URL plus this clocale, and then they're fetching it as an XHR. And I guess they're doing that to call the locale cookie. Now, there's probably better ways of doing this than calling your HTML again. Like they could set the locale in a server timing header and then fetch that via JavaScript. They could set the locale. They're already setting the locale in a cookie on that redirect, so they really don't need to make that request a second time. So they probably have the locale, but if they didn't have the locale, they could, there's probably other ways of doing that. So yeah, I'd be very careful about sending duplicate HTML requests because that can be dangerous if you're not caching.
Same goes about like maybe they could request a special page that just does that and not just the current page again, right? I mean, again, with this page actually being cacheable in the CDN, this is less of an issue. But I can tell a story when our analytics integration team needed to know if current page was error page or not. So they made a request to the current page to read the status code from it. And we were like, God, we are like trying to scale our systems, and our own analytics team is killing our own servers by doubling the load. So careful with like this kind of easy solutions. Sometimes the easy solution can be very, very costly.
Yeah.
Alrighty. I see that Samar is saying that the page actually had around 100 images, and so Cloudinary might be even optimistic about the reporting. And by the way, folks, I might sound a little sarcastic, and sometimes I'm like, yes, I'm like having fun of it, but reality is like everyone can have challenges like this for various political, technological, and historical reasons in their property. So don't feel like it's okay to chuckle. Like look at your own website.
Yeah. Alrighty, so let's move on to the other site. So looks like I'm gonna move this over here. So someone had requested us to look at oslo.diamondleague.com. So why don't we go, and by the way, just a quick time check. How much time do we have, Sergey?
We have about an hour.
An hour?
About
really?
an hour.
Okay.
Yeah. Total.
Alrighty. OsloDiamondLeague.com. So I'm going to kind of go through some of the things that we looked at before, like in terms of Trio. We'll take a look at what some of the real user measurement data looks like for that. And then I also want to take a look at, where did I put the SimilarWeb? Let's go and search for that as well. So, where did I have too many windows open? Okay, so there's the Crux data, and there's the, so yeah, there's no information on this, but it is saying that Norway is the bulk of the traffic, and then 20% is United States, and then 15% is Singapore. So let's go back to the Crux data. time to first byte is looks like it looks like that's improved considerably. It was really good last year, and then it took a turn for the worse, and now it's kind of on the it's improving. So it looks like this site has made a lot of improvements over the past year, which is great.
Do you think it's just a coincidence and it just got better, or you think like people actually put effort into making it happen?
We can probably find out by looking at the site. Looking at traffic from Norway, so the largest contentful paint is 1.6 seconds from Norway. It's 4.4 seconds from the United States. So half of the traffic is in Norway. Half, like a smaller percentage of the traffic was in the United States, and that traffic is getting a much slower experience. It also looks like the traffic from the United States kind of took a break for almost a year, and more sports-minded people than me can probably have a good answer for why. But yeah, the site's very fast in Norway, but it's not very fast in the United States. So let's and it looks like Crux doesn't have enough data for the other countries. So despite SimilarWeb saying that Singapore is 15% of the traffic, I would probably question that based on the data that we're seeing in Crux. Let's go and take a look at the site now. But first of all, that very significant difference in performance between Oslo, between Norway and the United States makes me want to do a DNS lookup. And so they are using CloudFront.
That might explain it.
Well, so I think that it'd be interesting. So I'm in the U.S. I'm in the state of New Jersey. Let's actually go and see where my request is going to for CloudFront. So we've left New Jersey. And we wait because if I remember correctly, and I'm not 100% sure, so if anybody knows, correct me. But I think that you can choose which geographic regions you turn on CDN caching for in CloudFront. So I think that you could say that I only want to deliver content in the US, because I think there's different prices for different probably. Let's see.
I can imagine their hosting actually is in the European region, right, for AWS, and it's possible that by default it just does local CDN, kind of like region-related CDN, maybe. I don't know.
Right. So yeah, I'm not 100% sure. But where did I put? Oh, there it is. So yeah, it's not. It doesn't look like it's crossing an ocean because the latency numbers are too small. So yeah, it's probably going to a server in like the Northeast. So that's not necessarily it. But let's go and run a WebPageTest measurement then. So I'm going to run this measurement from
Oh, Paul, are you saying you still don't use the magical WebPageTest extension that lets you open WebPageTest in one click?
Is that the one? Is that the one that Sergey Chernyshov wrote? Because I think I've heard of
he's the guy. He's the guy.
Yeah, he's the guy. I've heard of that guy. Okay. So I'm going to run this test. I'm also going to run a test from the US because I'm really curious. They don't have a location in Norway, so I'm running from Sweden. I'll also run from New York. And I'm going to close some of these other windows out because they are just confusing me.
And that's a great, by the way, point for using different locations in WebPageTest, right? When you have a geographically limited audience, right, or audience that you concentrate on, and then the rest of the world, or like some sub audience or something like that. Understanding how different audiences experience it is very helpful.
Yeah. By the way, you may have noticed that, like, when I ran a test, the location I chose was New York. So if you are, let's say, running a test in from one of the public regions, you might be used to waiting for 100 tests to run, because these regions, like especially Virginia, is very popular. If you sign up for WebPageTest Pro, you get these premium locations, and there's never a wait. It's definitely worth getting a pro account for, and I'm not getting any kickbacks from WebPageTest for that, but I think that it's definitely a great feature that helps helps you kind of run these tests a little bit faster. Let's go back here. New York. So this page took 2.5 seconds. Norway actually took a lot longer. Or in Sweden, it took a lot longer. That's interesting. Let's dig in. Woo. Okay. There's some video. There's a lot of images. There's some massive JavaScript from YouTube, actually. So it looks like, and if we go take a look at this as well, like you can kind of see just from that pattern of that waterfall that, like, whenever you see like everything is just kind of waiting for something, or in this case, if we take a look at this connection view, you can see that, like, there's something that's taking a really, really long time that's dragging things out. Like that's something that I would definitely investigate. Like, what's going on with this YouTube? That is a lot of bytes too. So this is 742 kilobytes of content. So it's maybe like 20% or 15 or 20% of the entire page load is just one YouTube player request. It's a massive JavaScript payload. Going back here, I don't see any YouTube content here. So, like, where is here? No, that's not it. Oh, here it is. So
it doesn't look like a YouTube video, though.
That's Facebook. Yeah. I'm not seeing the YouTube content anywhere.
Oh, no, it's right out of the video gallery, right out under the carousel.
Oh, okay. I am going to probably regret clicking play here because it's going to make a lot of noise, but I want to see. I want to try to do is see how long these videos are.
Paul, when you have a chance, can you paste the WebPageTest URL into the chat?
Sure. So yeah, this video is 4.5 minutes. So let me go back to chat here.
I know Samar is probably doing a parallel investigation at the same time.
So that was the New York one, and this is the Sweden one. But yeah, that YouTube widget is really, I'm surprised. I don't think I've seen them that large before. There's a lot of JavaScript going on here as well, and a lot of these JavaScript resources are really, really tiny. 2 kilobytes here, 0.6 kilobytes. They could probably benefit from doing some form of bundling here. If you take a look at this one here, the 0.6 kilobytes of JavaScript, they actually sent 2 kilobytes of headers in order to receive 0.6 kilobytes of response body.
Yeah, and also time to first byte. Well, I guess it's time to first byte is pretty large. So you're spending all of that time just to deliver very little content, right?
Right. So this is the entire JavaScript file. I can show it on the screen, like in one shot, because you don't have to scroll. like that's something that I think they could definitely benefit from bundling. And if we look at over here, 0.6, 2.2, 0.7, I definitely consider bundling some of these resources into one of the larger bundles here.
Yeah, which is, by the way, surprisingly low amount of JavaScript for a modern website.
DNS lookup on this seems to be really, really high. So let's go back and do a quick lookup on that. I want to see where diamondleague.com is what we're using for DNS. So it looks like, I don't know what DNSservice.net is, but that seems to be the DNS provider that they're using. Yeah. So I don't know what DNS provider they're using. It's not one that I recognize. The part of the DNS lookup times here could be if they're not using a globally distributed DNS provider.
And this is the New York test?
That was the Sweden test.
Okay, even for Sweden test.
And the New York one, the DNS time was also really slow as well.
Oh yeah. Pretty straightforward optimization. Like the most the ultimate bottleneck, right? Like nothing happens until DNS resolves. Right?
Yeah. Now, if we look at some of the response headers here, you can also see that these are the CloudFront cache headers as well. So you can see that this is showing the Amazon Cloudflare POP, whether it was a hit or a miss. In this case, you can see that, I don't know what ARN stands for, but that's from Sweden. But this was a cache hit. And if we look at some of the other resources, you can see that they're all cache hits, right? And what's nice here is that they also list the cache TTL. So when it's default cache TTL, it probably means that they're caching whatever the cache control header said to use.
By the way, it looks like this is a very signed DNS server. Service.net is very signed something.
Okay.
So
maybe,
like basically don't always use your domain provider as your DNS host. Might not be the best solution.
Right. So this has a very short DNS TTL, considering that these resources are versioned. If I go back to here, you can see that there's this ID in the URL, and there's even a epoch timestamp in the query string. So this is something that is cacheable on the CDN. It's cacheable on the browser, but it's not cacheable for a very long time. It's cacheable for, I think, 3,600 seconds is an hour. So I would definitely consider caching that for a longer period of time. If we go back to here.
By the way, Samar is saying that ARN stands for Amazon Resource Name for specific POP.
Today I learned. Thank you. Okay, so what I want to do here real quick is I'm gonna say X cache. Actually, let's just do the X cache header, since that's the standard header that I know of. So in DevTools, what you can do, I showed you before how you could add a response header here. There's actually, if you go into response headers here, you can say manage header columns, and you can add any type of response header. So it looks like I already have X cache here. So I'm just going to add X cache. And now what I can see is when I, let's say I search for a domain, Oslo. So now kind of going down the list here, I can see whether these are cache hits or cache misses from the CDN. So it looks like all the first party content here was served from the CDN's cache, which is great. So nothing here went back to an origin server. Now, if we go back here, so yeah, all of these resources were all served from cache, which is great. There's a, but the cache TTLs are all really, really low, right? So I would definitely consider increasing that cache TTL. We can also go here and take a look at the cache control headers, and you can see that for the base HTML, it's 5 minutes. For everything else, it is an hour, except for what are you? Except for the font.
The video. Oh, it's a font. Mm-hmm.
Yeah, and the font is 5 minutes. Yeah, the fonts and the SVGs are 5 minutes. So it looks like, and these are probably controlled at the origin server. So wherever they're hosting their servers, it's because the CDN is passing through, like you can see over here from this default cache TTL, the CDN is probably honoring whatever the origin's cache control headers were and then sending that to the client.
Mm-hmm. Do you find it a common setup, or do you usually see the cache control is set on CDN level?
It depends. It depends on the CDN as well. I think that a lot of CDNs do the kind of the model of honoring the cache control header. Some CDN, well, I think all CDNs also offer the ability of creating separate cache TTLs that ignore the cache control header and just define the caching policies on the CDN. So I think a lot of it really depends on the CDN you're using and preference, I guess.
Mm-hmm.
So yeah, I'm just kind of eyeballing this. Like the bundling, I think, is one thing I would look into. The DNS is another thing that's adding like half a second here. The YouTube plugins are just massive. There's got to be a better way of doing this. So I would definitely look into that integration. Maybe there's an alternate library that, like this one, it looks like it's called YouTubeNoCookie.com. So this, I don't even know if that's the official, like, is that run by Google? Is that like a third?
It actually might be, yeah. I forgot if it is, but I've seen it before.
We are going to find out. That looks like that is going to CNAME to Google, and it's hosted on Google servers. So that is legit.
Yeah, nice.
I'm very puzzled as to why it's so large.
How big is the actual file?
The actual file here is where are you? Oh, here we go. 742 kilobytes, but it's 2.3 meg of uncompressed JavaScript.
I guess it is a new and improved YouTube player. What else can I say?
Yeah.
By the way, I noticed about something strange about the images. Can you scroll up to the waterfall of the images?
Yep.
You see how like they just like they start early on, but then they kind of like take forever. Why would that be? Is that you think it's like the basically bottleneck, like the bandwidth bottleneck?
So in terms of the like the are you talking about like the length of these
Yeah,
lines?
the pale bars, right? Like all the way to the bottom one, they keep going.
So all these requests are fired off at the same time, and then the server should be prioritizing them and serving them back. Like the fonts, even though the fonts got fired off at the same time, the fonts should have been returned first because the font should have the highest priority. Andy Davies had actually done a study on H2 prioritization across CDNs. I'm gonna see if I can find it real quick. H2
That actually, when we were looking at the connection diagram, it looks like connection was fully used. So I assume it's like
so
prioritization, competition for bandwidth.
Yeah, so this here, I'll share this again. But like, so this was some research that that Andy had done a few years ago. Actually, I think this is almost 5 years ago now, where there's some servers that were not properly prioritizing resources, and so high priority resources would get served later on. And you can see this kind of list of CDNs that pass and fail, as well as when they passed. And so it looks like CloudFront, I mean, we can rerun the test that was run for CloudFront, but, looks like I didn't know that test results expire. Today I learned. But but yeah, like I suspect that it's still not doing prioritization.
Well, WebPageTest had a lot of transformation in those 5 years, so yes.
Yes. Okay. What else do we have here? Why is this? That's interesting. 71 kilobytes. 71. Okay, so this is not gzip compressed. Oh, no, it's broadly compressed. That's interesting. That maybe is.
HTML.
What?
And
yeah, it didn't show up as any 0 bytes in, so I was confused because.
Oh, okay.
I think there was no. Yeah, there's no content length header here. But anywho, yeah. So let's take a look at images again. So this this image, some of the clues here, like file admin, processed, and then if we take a look at the response, we can see that this is served from the CDN, but it does not appear like it's served as a JPEG. It doesn't look like they're doing anything to optimize the image on delivery, but they might be the image might be, I mean, 256 kilobytes for hero image might be like optimal, but like let's actually go and run this test again and see. And then if we go, like, let's go to the opportunities and experiments. We haven't spent a lot of time on that today. So yeah, there's 24 page rendering JavaScript files.
Oh yeah, sorry, Paul. Folks, like, if you are the one who submitted the site, like, feel free to ask the questions. I mean, it's always awesome to have some interactive conversation if you have some specifics you want to know and all of that. Sorry, Paul, go ahead.
Sure. So this image here was 128 kilobytes. So it looks like this could still be reduced further to like 50 kilobytes.
Was it a PNG originally?
It was originally a PNG. So
Okay.
it was just a higher quality PNG. This one here is 128 kilobytes. So it looks like what they've done in this is they've resized it and they've compressed it. And as a JPEG, they were able to drop it down to 50 kilobytes. As an AVIF, it's even half of that. So yeah, I would definitely look into image optimization solutions for this, as well as lazy loading the images. There's a couple of fonts. They're using typekit fonts, which so they're using Google Fonts and typekit fonts. They're using 2 separate font services. They may want to try to self-host some of those fonts or pre-connect them. If we go back over here and take a look at where the fonts are being loaded. So there's some first-party fonts. There's the typekit fonts, and there's the Google fonts. There's a lot of fonts going on here.
And they are requested after request number, what, 70 something?
Yeah. So preloading the fonts could, I mean, there's a lot of Java. I mean, I would bundle the JavaScript. I would lazy load the images. I would probably preload the fonts, but I would reduce the number of fonts it's probably worth looking at like where are they using these fonts, because there's certainly a lot of them going on here. I think if we go into DevTools, there is a feature in here called CSS Overview, where we can actually capture an overview and look at fonts and see like where they're using certain types of fonts. So like Font Awesome is being used in just a couple of locations. So like this little thing over here, like this icon over here is using Font Awesome. Where are they loading Font Awesome from? So maybe that's one of the ones they're using first party for.
Yeah, most likely some kind of framework situation going on with JavaScript.
Font Awesome here is a first party font, but and it is 64 kilobytes, but they are using it. Where did you go? They're using it for this.
For 3 different icons. It's Font Awesome. It must be icons, right? So
yeah, it's just
replacing them with small SVGs is probably the better.
Right. Let's take a look at what some of these other fonts are. So in one of the Google fonts, I can't really tell what they are from the Google fonts. Let's look at Typekit. Can't really tell from there either. I'd need to go and actually look at the CSS to figure out which font is which. But yeah, I would definitely go through this and try to understand, like this Lucidia Grand is only being used 3 times. Where is it being used? All the way down here.
It might have reloaded the page as you accepted the cookies.
It may have been on that cookie page that it was being used, but let's see. Yeah, something in this Facebook widget's probably using this one.
I think you can right-click and say scroll into view or something like that on those elements, right? Or click like that. Yeah, there you go.
Right. Did not realize that.
Yeah. I learned recently when I was showing my kids how to do this.
Yeah, in general, if you're seeing a font that's only used in a handful of locations, I'd question whether it's worth still using that font. Let's see. Okay. Inadequate cache settings. So yeah, we talked about that before. How a lot of these resources should be cached a bit better. Some layout shifts. Main thread blockage. Oh yeah, we can look into that one in just a minute as well. Single point of failures. So Typekit is a single point of failure, but they're using that for fonts. Yeah. What else do we want to look at here? Yeah, so just I guess just kind of summarizing so far, DNS. They should definitely look into using a globally distributed DNS provider. Maybe bundle some of their JavaScript. It is the Typekit. So they probably want to consider self-hosting their fonts and limiting the number of fonts that they use. Typekit does this thing here, which I always found intriguing. I never understood quite why they do it, but like if you look at this here, so this request is giving you your CSS for the for that particular font. So this is all the font faces. But if we go back and we look, there's another third-party request loaded from Typekit. It goes over a separate domain, so there's a separate DNS lookup, TCP connection, and TLS handshake, and it's 5 bytes, right? And if you go and actually look at what this is, it is a comment. So it is an HTML comment. And
Interesting. It might be some monitoring, right? Whatever CSS loaded.
yeah, I'm sorry. What I think this is analytics.
Yeah.
But like it's analytics that, like, because they're not injecting JavaScript, so how else do you trigger analytics?
Yeah, that's good.
But it's doing analytics over a separate domain name, which is requiring a separate connection.
And I can imagine that it is also a blocking CSS request, right? Because how would you do that?
It is blocking. Yeah.
Nice.
Yeah. It is blocking. And yeah, it's cacheable. It's cacheable for a very long time, which is nice. So it's not going to happen on every single page load. But yeah, if I was TypeKit, I'd be looking at ways to collect the analytics on the domain name that they've already established the request on.
Oh, and I see that also all of the JavaScripts are also blocking JavaScripts, right?
Yeah.
Yeah, which I'm always fascinated how images are low priority, but JavaScript is high priority for developers, right? At least based on what they actually load, not based on their mental attitude for it.
Yeah.
And I don't think it comes from malicious intent or specific desire to load JavaScript faster. It's probably just misunderstanding of how resources are loaded on the page.
Yeah. So I'm going to go and right now I'm emulating a Samsung Galaxy device. I'm going to go and in the Elements tab, I'm just going to delete the entire body so they have a blank page. And then in the Performance tab, I'm going to click refresh here so that we can collect a performance profile. And what that does is that allows me to have the screenshots start from blank. So it's not like refreshing the page.
You do know that you don't have to do it anymore.
You don't?
No, Performance tab was improved a few months ago where you just reload and it goes to blank page. And so we don't need to do it anymore, folks. You see, small happiness.
Thank you, Google.
Yeah.
Okay.
Like, nice.
Alrighty. So the reason why I ran this is because when we were looking before at this measurement, we're seeing there was a lot of total blocking time. I'm not actually seeing that here. Like I see some blocking time, but it's not as excessive. But let's go and take a look at the trace anyway and see if there's anything that we can learn from this.
I mean, it's still a blocking time, even if it's late in the page life cycle, but it's probably less important, right?
Right. So let's actually go up until this animation starts. Right. So I'm just going to filter like this, and so now I can see all of the resource loading.
I'm sorry, Paul. Did you just press some key to end the filter where your cursor was?
What do you mean?
Or did you just drag?
I dragged.
There? Okay. Sorry, I misunderstood. I thought you know the secret key to operate the range.
No. If there is a secret key, someone share that in the comments too.
Yeah, I know Samar might know some secret magic to do that.
So this is just showing the network requests. But then we can go and take a look at the flame chart to see what was actually happening. Where's the...
You're looking at frames, not flame chart. I think you expanded the animation section and it takes a lot of space for you.
Where did it go?
It's still expanded. There we go.
There we go. There we go. Okay. So I'm gonna make this a little bit smaller. And so now we're still just looking at this time frame up until this starting to load. Actually, let's zoom in a little bit more. There we go. So here's a long task, but I think that might actually be one of my extensions. Can't really tell what it is. Okay. Oh, profile. This is profiling overhead. Okay. So over here, we've downloaded the HTML, and now we're starting to load some of we're parsing the HTML, and then over here is where we've got some of these long tasks. jQuery.
Looks like Java.
Yeah. And then this one here, there's a script eval for vendors.js. So that took a tenth of a second. Not seeing a whole lot that is concerning about this phase of the page load. Let's move on a couple of seconds. A lot of it is there's not a whole lot of activity here, and I think that the reason why there's not a whole lot of activity there is because the browser's basically just in download mode, just downloading a lot of content. Yeah, if we look
it looks like a lot of it fires on unload.
Yeah, if we look at CPU utilization, the CPU utilization is really, really low, and doesn't get high until after the DOM content loaded. And there's a couple of block events there, but there's not a whole lot going on until later on. So let's actually go here and take a look. One of these seem like timer events. No.
It might be that animation, literally like just firing events of redrawing these frames and everything.
Mm-hmm. Yeah, not really sure that I'm going to be able to find anything in this. What else can we look at on this page? Let's look at the HTML. So
a bunch of blocking JavaScript. Here we go.
There's a bunch of blocking JavaScript.
One of them is deferred for some reason.
Okay.
second to last one is deferred. The rest of them are blocking.
Right. Yeah. So everything is blocking except the deferred one. We've got Google Analytics. We've got an old version of Google Analytics. And then we've got Google Tag Manager.
By the way, if anything, folks, you need to migrate to Google Analytics. I think they're discontinuing it soon.
So there's not a whole lot going on in the head, which is nice. It actually reminds me, there was Rick Viscomi had released a Chrome snippet. I'm trying to find it.
Capo.js, right?
Yeah, it was Capo.js. If you could find his Rick's blog and share that in the chat, that'd be great. But I'm going to go into my sources. And so when you go to sources, the sources tab in DevTools, you start off by seeing like just all the resources that were loaded on the page, and then there's file system and overrides. But if you go a little bit further over in the menu, you'll see content scripts and then snippets. Snippets are little pieces of JavaScript that you can reuse. So like you can see, I've got a couple here that I use for Etsy for looking at A/B tests and one of our APM solutions called Honeycomb and so forth. Capo.js is a script that Rick Viscomi had put together that takes a lot of the work from Harry Roberts' Check Your Head talk and does some really cool stuff with figuring out like the order of your head and if there's any optimizations that can be made there. So I'm just going to go and run this. And so what this is actually showing you is the actual order of the head, right? And then the sorted order of the head. right? So you want it to be like red, orange, yellow, green, and blue, but this is the actual order. And so what's really cool is like when you expand this, it actually shows you the HTML and it shows you like what you're doing that might not be as efficient. In this case, loading the Twitter JavaScript and Google Tag Manager above the title is probably going to impact performance in some way. So, but yeah, so you can see that like this is the order that resources are being loaded in right now. Meta viewport should be closer to the top. The title should be higher than these third-party scripts, and so forth. In fact, these third-party scripts should be close to the bottom of the head. And then there's something. The viewport is the So now if we actually go and look at the sorted version, this is what the head should look like, right? So I think this becomes definitely worth running an experiment on and seeing like if you reorder the head, is it going to produce a faster experience?
I wish each line also on it, like had the linking to the documentation for why. Might be a good, if anyone wants to contribute good open source, just go into basically do a PR for Kappa.js, adding documentation. But generally speaking, like some of these are quite interesting in a sense that like you want UTF encoding because until that is sent, you either shouldn't send it because it's actually default, or if you send it early because browser can actually change its mind about how to parse the page and actually discard and basically redo the pre-parsing, right? And things like that for the rest of them as well.
Yep. And it looks like you found the link and shared it in the chat.
Yeah.
So great.
Yep. I found it on GitHub, so yeah.
Right. Do we have any other no other submissions yet? So
we do have petvalue.com .ca, but we do have like 18 minutes left, so we can start it if you like.
Let's take a look. Petvalue.ca.
Yeah, we were looking at another pet store last time around.
That is really interesting.
What are they trying to get your location or camera?
They're trying to get my location, but because they can't get my location, it's completely blank on my screen.
Huh. I think we found optimization.
Yeah. There's nothing, and it will be super fast.
Yeah.
Let's actually go into WebPageTest and see if we have more luck with WebPageTest.
Yeah.
I
guess if you are not in Canada, the buying food for your pets is forbidden.
Well, I wonder. We will run this from Canada, and we can also run it from New York is the closest location to me. So, and I'm going to close some of these other tabs. Test is running in Canada, New York, and why, oh why, are you doing this? Very puzzled.
Well, can be a very simple bug in your JavaScript that does something wrong.
Right.
You know.
So I'm gonna try now. I'm gonna try this amazing feature that I did not know existed, which is clicking the refresh button, and it should clear everything out for me.
Not for long.
We can try to figure out what happened. What happened to poor Paul's browser? In the meantime, we can also look at both of these experiences were much better than mine. Please confirm your store.
Yeah, it's probably a little too aggressive about wanting to know that.
Right. But like I did not allow it to have my location, and I think that may have like we can actually go zoom in and try to figure out like what happened just before the page went bye bye.
So basically, the question to the product owner is: e-commerce not important for you? Is every only thing you want is to send the person to real store?
You're brutal.
Sorry, I am like I like to pose it as in the user, went and like just look. I might not want to tell you where I am right now. Do you want
Yeah,
me to as a customer? Like that's reality. Right?
yeah. Okay, so we've got some performance data. I know we only have a short amount of time, so let's go and zoom through this. Whoa, that's a long waterfall. Um,
Yeah.
okay,
Well, I guess that's a new trend, right? 479 requests. That's good.
let's take a look at response header. So they are doing some geo lookups as well. Um, so they've got the country code, the region code, the city, and the county. Um, they should be able to start with a geolocation with some of this data as well. I mean, they
Okay.
obviously need your precise location to tell you what store you're closest to, but I feel like they could start with this. Um,
I mean, I've been sarcastic. Sorry, it's literally just a bug of some kind, right? Like
yeah,
that might be
this
or
is
might be a use case they never thought of, right? Like if user declines to give you information, you should work out right.
yeah. Now this is cache control private, no cache. No cache does not mean do not cache. No cache means that the browser must revalidate a cached resource,
Mhm.
which is confusing. It's one of the worst named directives in HTTP, in my opinion. But yeah, this doesn't mean don't cache. So if the intent is to not cache, then they should use no store.
Mhm.
Um, there's a Google Fonts that for third-party requests that's loaded over here. Um, it's loading a couple of different font libraries.
I
Um,
think Brenda is saying 100%. I think she appreciates my brutal honesty, right?
and then we've got images, and a lot of them. Um, so it looks
That's
like
not bad.
it
That's
looks
like
like what's interesting is that there's one JavaScript bundle, and it's not even render blocking, right? And
Mhm.
then there's just this wall of images, and then a bunch of fonts, and then a bunch of JavaScript files. Now these JavaScript files are also really tiny as well. So
Mhm.
there could be some benefit to bundling here. Um, the amount of scripts that they're loading seems excessive.
Well,
Um,
there it looks like they're not bundling anything. Like they probably use some kind of front end framework that just
yeah,
doesn't do bundling. Period. It's like everything is loaded.
yeah, and you can kind of see that over here as well, where there's like hundreds of tiny little JavaScript files.
Yeah. Well, yeah, that's
That's
probably good advice to do that.
yeah. Um, so yeah, I don't. I mean, they're using a lot of fonts. They're using a lot of these super tiny resources. If we look at bytes downloaded, the largest resource that they have is request number 450 and 451, which are two JavaScript payloads. Which, by the way, there's more than 450 requests. Um,
Yes. Yeah.
right. And so these are actually render blocking, but they're loaded so late that it probably doesn't matter. Um, the
Do you think the browser would just ignore that and will start rendering early?
I wonder if I mean I wonder like if we look at the page stats here, like the start render was really
Yeah.
really the first contentful paint was really really fast.
It's
But
also possible that they're actually included at the bottom of the page, or even they
yeah,
might be blocking, but they might be blocking the bottom of the page, right?
yeah,
Although DCL fired sooner than that. if I understand.
Yeah, no, they're blocking from when they're injected. So at that point,
Yeah, okay.
they're blocking, but they're not. But the page has already been rendered, and the largest contentful paint has already been like long fired and everything. So like it's blocking, but it's blocking from the perspective of like it's another long task, and you can kind of see.
It might be actually a widget of some kind because it looks like it's a different domain and all of that.
Yeah. This is Fresh Chat. So this is actually their chatting library. And their chat
Yeah, the
library.
chat
So
widget. Yeah.
this is a third party. Let's take a quick look at their third party. So it looks like this is hosted on S3. They're broadly compressing it.
Oh, really?
Yeah.
It is hosted on S3, but they're okay. So it is
It's
actually CloudFront. Okay.
it's so yeah, it's hosted on S3. It's served via CloudFront, and CloudFront is broadly compressing it.
Really nice. I didn't know that CloudFront could broadly compress actually.
It does, yes.
Okay.
Let's actually go and see what I'm curious to see what compression level they're using. So a trusty web compression tool. And they're doing broadly level 6.
Okay, that's very good actually.
Yeah, so 1.8, 183 kilobytes versus 200 kilobytes. So it's not a huge savings, but it's definitely something.
Still 700 kilobytes of JavaScript to show a widget, but yeah.
Yeah. And how much? 700 kilobytes of JavaScript.
It's funny how we got completely desensitized to this. The amount of code is like, yeah, who cares, right? Like we've seen worse. You know what I mean? It's kind of like mind-blowing.
It's nice that this is at least not blocking the user experience. And I wish I could tell you if it was blocking my experience.
Something much earlier in the game blocks your experience.
But yes.
Yeah. But in fact, it probably is blocking. It's just doing that through parsing late and execution late, and it's basically the INP metric would be bad for it, right? We just only starting to get better at measuring like the main thread blockage.
Yeah.
It didn't become a norm again.
This one here, uncaught error window UID is not a function. This error seems to be what is triggered just before my screen goes blank.
Yeah. Might be a simple fix, folks. You know, if you manage your location service.
It may be. So another thing that it could be is, so I'm using uBlock. Where are you, uBlock?
It's uBlock origin right there in the middle.
Did you see it there?
Yeah, it was there on the list. Yeah.
So, can I trust this site? Do I want to trust this site? Do you know? Is it possible to?
Nah, I don't think it's possible to whitelist allow listed.
Let's try that. I'm just gonna.
Be careful, or it will explode.
So that's it. Oh. So I'm using a very popular ad blocker, and because I'm using that very popular ad blocker, it's trashed the entire experience for their site. And that's something that we didn't see in WebPageTest because WebPageTest is running kind of a clean room test. But this is a real user experience, and lots of users are using ad blockers. So that's something that they should look into testing. Obviously, you can't predict what extensions are going to be used by your customers, but you could probably go for some of the top ones for e-commerce. Like you should test it with AdBlock and uBlock Origin and Ghostery and a few of the others. But you can also test like the Honey extension, and I don't have that installed here, but like that's another popular one for like coupon, like clipping with e-commerce, but there's so many extensions that could have an adverse impact on your user experience. But also, if your site is doing this, I like that. That's something that I would look into, like testing with a couple of different extensions and see, like, what might be causing that. Now I'm going to go and turn all my things back on and refresh this, and I'll probably get no pet value from me. But
and you probably could collect this in your RAM, right? In your maybe not in the RAM, but in like maybe tools like Sentry or some other.
What you might be able to do is get so some of the some third-party extensions will load will like fire off requests, and those can be captured with resource timing data. There's probably ways in the DOM to profile to profile the presence of them, but I don't know enough about that to really say for certain.
Yeah. It's a challenge that is, like we are running the browsers that we don't control, and then on top of that, the users actually control them. So what actually happens is complicated even more. But yeah.
Cool. Well, I think that we're just about at time.
Yeah. Thank you, Paul. It was awesome. Folks, if it was your website, please bring this back to your team. Give them the feedback that we were able to give. Like, look at what can be done, and we'll be happy to see you next time when we fix it. Like we did follow a few websites over the years there where like folks were making fixes, bringing it back, and stuff like that. This was a very interesting. And Paul, you learned something today, right?
I learned lots of things today.
Yeah, like how can you make 500 requests per page? That's interesting.
Yes.
But yeah, thank you everyone for visiting, for listening, for submitting your websites. I mean, it's always good to see that you find it useful. Please continue doing so. And if you are in New York City, in fact, and you want to host in-person events like this, please let us know as well, because we want to figure that part out too. And we hope to do streaming there as well, just to combine the two formats, because I know many of you are not local New Yorkers. In fact, I believe everyone in the chat was not a New Yorker, except for me and Paul.
I'm not a New Yorker, and neither are you.
That's true. Little secret that neither of us are actually in New York City. But it is a New York Web Performance meetup that brings you the best of web performance between the big conferences, which is quite a long time these days. Speaking of which, by the way, a big announcement for Perf Now conference in Amsterdam that is opened the registration. So if you want to be there, if you want to do performance, you want to be there. So please sign up. They are not sponsoring us, unfortunately, but it would be awesome if they did. So again, thank you, Paul, for all of the analysis. Thank you, everyone, for coming. We hope to see you in person next week and virtually at the next event next month. Take care, everybody.
Everyone.